Okay, hello everybody. The presentation will start shortly. I would like to just repeat information about the lightning talks. There are lightning talks scheduled 5:30 today, and the topics, you are open to propose some topics for your lightning talk that you would like to give. It's like 10-minute talk. You can write it on a whiteboard that's just upstairs, and you can also vote for the talk that you would like to hear. And now we will start with the next session. You can start, Karel.
Hello everybody, can you hear me fine? Okay. So hello once again. My name is Karel Piwko. I'm working in Red Hat as a QE engineer. I'm currently leading mobile QE related efforts in Red Hat. And I'm here to present you Arquillian Spacelift, which is a tool that we developed to make testing easier for us. I would like you to get familiar with the tool and ideally try it after the session and report any issues you can encounter. And if you are happy with the tool, please include it in your testing tool belt. So what was the biggest problem we've been facing while trying to automate stuff? We are coming from the Java world, and Java once did a very nice thing that they claim that you will just write the thing once and you will be able to run it everywhere. However, it's not exactly the true, because there are some differences. So one of the things that are different while you are trying to run Java program, you still have external dependencies, and that's especially true when you are testing something. So for instance, if you are testing in web UI, you need to have Firefox installed on your machine. However, the steps to install Firefox is not the same on the platforms. You have an installation for Windows, for Linux, for Mac. The steps are not the same, and even Mozilla itself, they provide 3 distinct tutorials how to actually install the thing. Once you manage to install the thing, you would think that it's the same, but it's not. So you have a set tool and you are familiar with its syntax. However, if you are running on Solaris, one of the parameters is not there. So you thought that you would be using a shell script to automate the stuff, but it's not working anymore on some platform. And even if you have same tools, same platforms, that are differences. You can try to spot 10 differences in this image. The point is that 2 developers, that they might have a different environment. There might be an environment property which is set to a different value. A program that you are running is dependent on this value, and it takes a really long time to figure out why the test is not working, because it's pointing to a different location that you would expect. And there are more problems that are related to make sure that your scenario is reproducible. Such as runtime dependency. So you don't only are required to have tool there, but you want it to be in some state. So for instance, you want to start a database. So just having the database on a machine is not enough. You have to have it running and having some scheme there, have it prepared prior you execute your test suite. So this is another problem we are facing. And you are usually testing system, but if you think about it, it could be, and most likely it is, a system of systems. It's not a single system, but you are testing against a cloud where you have multiple machines there, and these together create a system that is under test. So it gets quite complicated. So in the end, your daily work as a tester looks like you write once, or to be more precise, developer write once. But you as a tester have to set up it everywhere. You have to write test multiple times, if you are lucky, just to cover platform differences. But if you are not lucky, you have to test the same stuff using different tools because of the differences. And the biggest problem is that you discover a bug and then somebody tells you, hey, I would like to reproduce it on my machine. And you literally will bang your head against the wall, because it would take 3 days for a developer to establish the environment so he can reproduce the issue, because you would have to tell him to download the all the dependencies, to install them in a particular manner. You usually don't have this stuff documented. You know, this is like a common knowledge in QE that you have to have some tools on your machine, but developers are not having these tools. So these are the challenges for QE, and I would like to go through our own department. I would like to show you how we are actually testing and what are the challenges we are facing and how this relates to that. So in middleware, we are required to test our products on different operation systems. So, you know, we could use Docker now when we have Docker, but it doesn't solve the thing because we need to make sure that our product is running on Windows. And boot to Docker on Windows is not Windows, that's Docker on Windows. So our test has to be compatible across different multiple operation systems. The scenarios we are testing are running in are composed of components written in different languages. So you can, for instance, think of web server that is written in Express.js running on top of Node.js, and another web server that is written in Java. And those two guys have to communicate together, and you have to prepare your environment and your test to start both, deploy something on both, and verify that it's work correctly. We are also using multiple CIs. So we are having Jenkins instance, we are using Travis, there's TeamCity instance. So we can't really rely on CI to bring all the environment for us because the CI is different, and keeping same setup across different CIs is very hard to do, if not impossible. And obviously, most of the time, we are running the same test suites on our local machines. So even if we would have set up in CI, that would not help us much because we would need to replicate the same setup locally, which is, you know, you guys probably all have seen a new hire guide that could be 30 pages long that says that you have to install this, that, and more. Another thing which is specific to Red Hat is that we are testing in both community and products, and that means that we are usually having a single test suite that we are running in a community, and extended test suite we are running for product. And we want to be sure that we are able to propagate tests back and forth, so we don't have to manage and write them twice. So why Spacelift, and what actually Spacelift is? Let me ask you a question. Are you guys familiar with Arquillian testing framework? How many of you are familiar with Arquillian? Okay, half of the room more or less. So Arquillian is a tool that started as a side implementation for testing CDI in Java. That's how it started. But as a platform, it's highly extensible. It has a concept of plugins and containers and that kind of things. So it provides you a test bed how to test anything Java related. That was the start, such as running your test directly in containers, multi-container scenarios. But later on, functional tests, transactions, persistence, REST APIs, and so on. Spacelift is actually, and Arquillian, you know, you might have seen Man in Black. Arquillian is one of alien characters there. And Spacelift is actually a tool that brings another things to the space for Arquillian to be able to use it. So what are we trying to achieve by developing Spacelift? We are trying to have an abstraction of a system we are testing so that you can work with a system in a platform-independent way. While you are writing your test, you don't care whether it would be running on Windows or Mac or Linux. It doesn't matter because you are abstracted. We are connecting different components together. That means that Spacelift provides you a glue that makes able to start a Node.js process execute something within this process and pass output to a Java process. So you can easily combine stuff that you have and run it in a system test scenario. We are also using Spacelift to be able to share tests in between community and products because Spacelift is open source. It does have an extensive pool of tasks that are available, and obviously it's extensible, so we can still have some internal tasks that we are hosting internally. And obviously, I was talking about testing systems of systems, and Spacelift is a way how to define complex test scenarios and how to bind them all together. And if I'm talking about complex test scenarios, I do have an example for you what I consider a quite complex test scenario. So this is an integration test, which can be also considered as a system test. We do have two major components here. One is a server side and one is a client side. For this particular scenario, let me, for instance, give you an example. Server side would be a unified push server installation somewhere on OpenShift, for instance, which is a server that is able to receive REST messages and send, according to these REST messages, send push notifications to your mobile phone. And on the client side, we would have, for instance, native Android application, which will register to this server and then receive a message. So what test will actually do, first it will start the server, it will bootstrap it on an OpenShift, and then it will communicate with the server in order to create data there that would be later used, will be grabbed from the server back to Spacelift, and this data will be used to alter the template of the Android application. So when the Android application is built by Spacelift, it actually contains correct URLs that have been fetched from the server. So once you start the application, it connects immediately to unified push server. This can be considered as an orchestration, and then we can proceed with a test run. So you can interleave these tests in a manner that you can perform action on a client, on a server, it doesn't really matter. What is important is that you can interleave them and you can switch easily in between contexts. So you can verify that what you've done on server side had an effect on client side. For instance, you sent a message using web UI in your Firefox browser, and then you verify that this message was indeed delivered on Android application. In the last part, once you are happy with the test results, that is all the assertions passed, Spacelift will do tear down part. So, it might, for instance, delete OpenShift cartridge that was installed. It can uninstall the application, whatever you want it to do. So I'm talking all the time, and I guess that you guys want to see some code. So let me dive into code and let me show you what actually Spacelift is. So this is how we started. As I said in the beginning, we are still in a majority a Java shop. So we started with some Java API, and we made it fluent and type safe. So it's basically verified during compile time that you haven't done anything wrong. So here what you can see in the first block, we do have an entry point that is called Spacelift, and we do have a task. Task is basically something that can be performed and can be chained. So in this block, I'm using a download tool task. I'm downloading the stuff from some particular URL, and once it's downloaded, I pass it to unzip tool and I'll unzip it somewhere. I can let it execute in background, that's a default, and I can retrieve result later on. I can also use these tasks that are that are able to be chained to pass them an input without using another task. So this is like a fluent Java API that makes it quite simpler, at least in my opinion, to do the stuff. Let me show you another tool, and we do have a set of let's say 20-30 tools and at this moment, and we are working on deliver more abstractions on top of this. So this is a basic tool that interleaves with cat process that is a default, that's the thing which exists in Linux, and it basically echoes the input. So here what we are defining, we are running cat process and we are interacting with it. So when it starts, we put some input in. When we check that in the output of the process there was some string, we do something else. And in the end, when we discover that somebody has written Spacelift into the process input and it appeared on output, we terminate the process forcefully. So this is a nice way how to, from Java, run any process so far. That's nice, but how does it actually help to solve the problem? Well, it doesn't. It's very nice Java DSL on top of native processes, abstraction of tasks. You can have tasks hosted in your repository. You can have a very huge list of tasks, but it doesn't really solve the problem of platform independence and that kind of things. So that's how we started, and we've been working for some time on making the idea better. And what we did is that we added Gradle to the mix. Are you guys familiar with Gradle? Okay, half of the room again. If you are not familiar with Gradle, I hope that you are familiar with Ant or Maven. Gradle is also an automation tool that is able to bring dependencies to your project, that is able to define the build steps, compilation steps, publication steps. What is important with Gradle is that it's written in Groovy, and it has a very nice way how to specify a DSL or write your own domain-specific language. So with this Gradle thing, we thought, wouldn't it be nice if we can reuse existing tools that are already installed in the system, such as a cat tool or PS tool or kill tool? That would be nice, but it wouldn't be enough because sometimes you have to install something. You guys might recall I was talking about Firefox. So why not to bring Firefox installation to the system and once it's installed, provide a tool called Firefox so you can start Firefox browser. So that was another step we've been thinking about. And the last thing is to define the tests themselves. And if I'm talking about tests, I'm rather talking about suite of tests. So a test can be, for instance, running Maven build. This is a test. So this Maven is running a suite of tests, but from Spacelift point of view, this is a single test. So you can run Maven build 5 times if you want, with different parameters. So this is how our DSL looks like at this moment. So you can see this is a build Gradle file, and we apply a plugin called Spacelift, and all the tools, all the installations, all the tests you define directly in this file. So here what I'm doing, I'm defining a tool called Maven, and I've omitted the inside parts of these tools for clarity. So I'm defining a Maven tool, and this will bind to a Maven installation that is already present on the system. Because I can do it. If I'm sure that Maven will be there, I will do it that way. However, then I realized that my test needs NPM and Node.js, and I'm not that sure that NPM will be installed on my Windows machines. So I will provide an installation for Node.js that will deliver npm tool. And then I'm defining my test. And in the test, you can see that I'm able to specify a data provider, which is a thing like to parameterize test execution. So you can return almost anything, and it will get automatically injected into execute method. So in this particular test, I'm before suit once running a Maven command, and I'm executing something. Let's say that I install a snapshot version into my local repository. And in the test itself, I'm executing it twice with two modules, first with module foo, second with module bar, and I'm executing some npm task. That's what Spacelift will do. And that's how DSL looks by default. It's still groovy. It can be easily extended, and we want it to be extensible. So the first nice thing we added there is that we added inheritance and custom DSL specification. So the installation can inherit from an existing installation or from an installation definition, which is actually class written in Java and Groovy. And this custom installation brings you the opportunity to define your own DSL. So by default, installation is something that downloads something from the internet and extracts it. In this case, for Android SDK installation, this installation is defining two additional properties, or maybe more, but two in this test. You can define Android targets you want to install additionally to the SDK itself, and you can ask it to create Android virtual devices. This way you can easily add additional properties to the DSL of build Gradle. So once you write your own installation, you are free to put anything there. That's the clean way, but there's a dirty way as well, that you can inherit from the existing stuff that was already defined in the DSL. So in the second example, I'm having a test one, which executes something on top of data, and these data would be first foo, and in the second run of the test execution, it would be bar. I can create test 2 that inherits from test 1. That means the data provider is inherited. And if there would be a before suite, after suite, before test, after test closures, this will be inherited as well. So this way I can easily modify the behavior and keeping build Gradle dry. It's still groovy. So, you know, often it happens that you need to write something very quickly in a dirty way because you don't want to mess with all the stuff. So this is using just pure Groovy plus the DSL. So in the build Gradle, I'm defining a test 0 that contains, for instance, some abstract methods such as data provider. And then I'm just calling Groovy, and that is, I'm creating 300 tests in the DSL, where each of these tests will be named test 1, from test 1 to test 300. It will inherit from test 0, and as a before suit, it will call a Spacelift task that I've defined in this build Gradle as well, and this task will actually ask for a value of system property pass. So it's quite useless, but you know, it's a nice way to show you that you can do anything in the build Gradle itself because it's still groovy. So how we are using all this stuff together, the build Gradle, the Spacelift, and Arquillian tools. This is an image which kind of describes high-level overview of a system under test. So you can see in the bottom that you have either an image or a hardware. So you are running somewhere in the cloud or on a local machine or in Docker. It doesn't really matter. All of that is controlled, all above the image or the hardware part is controlled by Spacelift. So in yellow, we do have our Arquillian umbrella. So Arquillian is able to test Java code by using JUnit and testng. However, we are able to test also JavaScript-related code using Arquillian QUnit extension. We are able to test on Android and iOS devices using another extensions called Droidium and Osmium. We do have a reporter that is able to report the test execution of these tests. Then we have Spacelift. So if there's any other tool that is not directly supported by Arquillian, we can use Spacelift to create a binding and be able to run this tool anywhere within the test. And by the green part, that's actually something, a combination that we are testing very often in mobile QE. So we do have a unified push server or another AeroGear components, which is related to mobile development, and we are running these components either on a local machine on top of different products such as EAP or in OpenShift as a cartridge. And we use Gradle, Maven, and Grunt to bind all this stuff together. So you can see here that Spacelift doesn't require you to learn that much new stuff. It's a glue that allows you to reuse existing stuff, existing tests. Once your tests have been written and they are written in JUnit, for instance, you can still reuse this test, but you can let Spacelift prepare the environment for your test in an automated manner. So you can easily move this test suite from CI to local machine, however you want. Let me show you an example. I will go to a real build Gradle file, and this is on GitHub. So you guys will be able to run it yourself afterwards, or maybe even during this presentation, but if you will execute Android installation, it will download Android SDK, and the images, which is about 1.5 gigabytes, so you will bring the internet connection in this room down for sure. So this is our build Gradle file. So the same, is it big enough? Should I make the font a bit bigger? Okay, I will make it bigger anyway, so I'm able to see it. This is the plugin definition. As you can see here, on line 31, I'm defining a Java tool, which is basically the only external dependency to run Spacelift. You have to have Java installed. And for Spacelift purposes, I'm defining a Java command that binds to a binary that is available on a pod, and it's in a platform-independent way. Then I'm pretty sure that Maven is installed on my machine, so I'm retrieving a Maven location, and I'm creating a command to run Maven. Later on, you can specify profiles. So if you have a really long file and you want to keep it in a single place, but you want to be able to execute, for instance, only 3 tests of the 20 tests you've defined in build Gradle, you can use profiles to that. Profile is basically a combination of installations and tests that will be executed. So I've defined like 4 profiles because this test case has 4 different test cases. And as for the installation, this test doesn't require much thing, but we are installing Android SDK here. We are, after the SDK is installed, we also install some Android targets that have been defined in the top of the file, and then we modify Arquillian files to point to write Android home and Android SDK home. And then the test itself. So if I go to Droidium scenario, I will execute it twice for each of the Android targets defined in the file. I will execute a Maven run. And basically here, that's just executing Maven. But it's pre-configured, it has everything it needs for its execution. In the very same way, I can run my different test scenario against multiple browsers. So I can define, for instance, Firefox, Chrome, Phantom.js, Internet Explorer browsers, and then run a test suite written in Maven. So I already had this test suite written prior experimenting with Spacelift. But Spacelift brings me a way how to easily let this Maven test be run it multiple times and have all the dependencies for the test defined in a single place. And it goes basically the same way for different tests. So let me execute the test. So this is how you execute. You have a Gradle. Basically, it's a good practice to have Gradle there. You can ask Spacelift what are available profiles, what are available tests and tasks. And once you see that you want to execute, for instance, Android test, so this is maybe something you are waiting for. And if you like mobile testing, I suggest you to stay in this room and visit the next presentation from Tadeusz Kříž. He will be showing mobile testing, and he has some fancy stuff there. I think it's called Tapster, and it's really nice thing to see in action. So this particular test is actually testing a connection in between mobile application and web browser. So we can see here that Spacelift is starting an Android emulator. I guess that due to resolution, it will be quite complicated to see both stuff simultaneously on the screen, but I will try. So now it's starting an Android emulator. When it's started, it will install an application there. And then it will start a container. It will install an ER file into the container. It will do something in the browser. And then it will switch the context to Android and verify that this particular test is about tasks. So in a browser, I will define that I have to buy some milk, and then I will ensure that in my mobile application this was propagated too. So now it's starting the application server. So, you know, the test can take quite a long time, but as long as it is automated, you can run it on CI. It doesn't matter that much. So here you can see that in a browser, I'm interacting with the browser. So this will, it's waiting for some internet connection, but the browser part of the test will fill in the columns, hopefully, and then it will switch the context back to the Android device. So I'm logged in. Now you can see that I'm logged in also in the Android application. I'm adding ask in a browser, and what's going on? I will log in once again probably. Okay, and it failed. Okay. As usual, I forgot to sacrifice a goat prior making a demo, so that's happened all the time. Unfortunately, we don't have that much time to see what went wrong. The point was that this same test will be executed twice for a different Android version. So what's next about Spacelift? Spacelift is currently in alpha version. We have released alpha 7 this week. We still have plenty of features and ideas what should be implemented here, and you guys are all welcome to provide a feedback to let us know what you would like to see there. The first thing we would like to have there for sure is better reporting. Now Spacelift dumps all the output into console. We would like to be able to have some logs for the native processes that are in a dedicated location. Once this is done, we want to have even better reporting. So let's say that you are executing Maven, and Maven by default provides you a nice report after the test execution. This report can be propagated to Spacelift. So in the Spacelift console, you will see Maven results without all the Maven mess around. We are also working to have non-JVM based tasks. So Spacelift, now it's written in a way that it's using callables and Java execution service to run all that stuff. But we would like to move the implementation to some model that will allow us to natively execute tasks that are not defined in JVM-like language, such as JavaScript. And as part of the Spacelift, it's an ability to run stuff in background. We are working to identify dependencies in between installations and run installations in parallel. And same could be done for tests. So it would be much faster, especially if you have to download 1.5 gigabyte, you can be downloading different stuff at the same time, expecting that your internet connection is not the limit. If you guys would like to know more, go to GitHub. We do have a Spacelift wiki there. We do have quite a huge document there that describes what should be the future of the DSL. And it looks that internet connection is not working. Anyway, it is working, but it's quite slow. Maybe I'm downloading. No, I'm not, but I could be. So about that, seems that it's not refreshing for some reason. Okay, so to conclude, Spacelift is really about reusing existing tools in an innovative manner. So you won't have to you won't have to learn that much new stuff. You can also reuse the existing tests, so you don't have to write new tests. You can simply glue them together and make it easier for your CI to pick them up. You don't have to mock, because Spacelift provides you a way how to run services prior to test execution. This is important if you are running system test-like scenarios. It's not that relevant if you are running unit test or integration test, but integration test, that's questionable. But for system tests, you don't have any other option than to run real components and ensure that they are communicating each together in between each other properly. And Spacelift is also trying to be IDE and CI friendly. So within the IDE, you can run the test, and so you can do from command line. And the main aim is to be platform independent. So once you've written your test in Spacelift, you can run it and migrate from Windows to Linux to Mac to HPUX, Solaris, whatever you want. Do you guys have any questions?
So you are adding Gradle and Groovy to the mix, and my question is, do you have any experience, or don't you think this is a problem to introduce such a scripting layer on top of things that can change over time? Because I already maintain quite a big base of Groovy scripts that depended on some Java classes that could perhaps change, and it was quite a pain to find out what was broken through the changes in dependencies in Groovy scripts.
Yeah.
Okay, I will just repeat the question for the recording. So the question was whether Groovy and Gradle are not too big of a risk for maintainability of the tool.
So I believe it's not, because the point of Spacelift is that it will execute an external process. if you are running Maven test, it will run Maven externally. So it doesn't interleave. The dependencies in the plugin won't interleave with the dependencies in the system under test. Does it answer the question?
So
You know, it's a different class loader. So if you are defining tests directly in Java or tasks in Java or in Groovy, then yes, you might have a problem that the dependencies of the Spacelift itself will clash with the dependencies of the system under test. But most likely you will rather use Spacelift to run NPM test suites, to run Java-based test suite, and in this way it will be run in a different class path, so no chance to have conflicts there.
Okay, so we have already run out of the time for the presentation, so any other questions you can speak to Karel directly. Now we will take 10 minutes break and another session will start after that.